Okay, good morning, Algebra 2. So yesterday you guys were asking me if there's an easier way to find the zeros to a quadratic, and today we're going to take our first step towards that. So what we're going to do today is we're going to review a factoring for you guys. We're going to talk about the FOIL method. So everybody should be familiar with the FOIL method. And all we do with the FOIL method is start with two terms, multiply inner, outer, and then we end up with our trinomial at the end. So what we're going to do today is we're going to work backwards from that method. And I'll show you what I mean by that. And I think you all should remember this from Algebra 2. But before we do that, there's a couple of different techniques that we're going to talk about. The first step is using the greatest common factor. So we look at our binomial and we look for greatest common factor. Like from this example, the greatest common factor is a times b squared. We can factor that out of both. Next step, we're going to call this factoring by grouping, and we'll take a look at an example of that. I also want you to notice that when we have a difference in the square, so if the first term is a perfect square and the last term is a perfect square, then we can use a specific factoring method for that, as well as if the first term is a perfect square and the last term is a perfect square, but we're adding together here. Okay, so we'll take a look at an example of each of these. Let's bump down to our first example, which it says example 2, not sure why. We're going to factor by the greatest common factor. So I want you to look at these terms here. What's the greatest common factor? Well, let's see, 9 and 6 and 3. I can factor at least the 3. I can also factor a. So what I'm doing is by 3y, and everything that's left over is my parentheses. So 9y divided by 9y is y squared. 6 divided by 3 divided by 2, y squared divided by y. So voila, there we go. We've factored by the greatest common factor. And the next step we want to do, actually, we always want to look and see what we can look before we try any other technique. So the next technique I want to talk about is factoring by grouping. So what we're going to do, and we're going to look at the first left half and then the right half. We're going to do the exact same thing for a common factor in these two terms. And we're going to factor out the greatest common factor. I can factor out 2 by 2, and I can also factor out an m. So I'm going to divide by 2a, and I will get 4 divided by 4 squared divided by a, 2 divided by 2, a positive 5, and a times okay, so I've completed the left side. Now I'm going to do the exact same thing with the right side. The greatest common factor. So no common factor goes into 4 and 5 other than 1. I'm going to factor out, I can't factor out an a, but I can factor out a b. I'm going to factor out a positive, and I'll be left with 4a, and I'll be left with 5 times b squared. Now here's the whole goal of factoring by grouping. I get the same term here that I get here. Okay, and now here's where the grouping part comes in. I'm going to group 2a and b. I'm going to write this as 2a plus b. So I just got that from here, that from here. Then I'm going to combine these together, and it's going to become 1. It's going to be 4a plus 5b squared. And now if I multiplied all of these out and all of these out, I would get the exact same thing, and I would get right back to where I started. So all we're doing is we're working backwards from the distributive property and the FOIL method. Okay, let's flip over to the next page and look at our first example of a trinomial factoring trinomial. So remember what I said, basically we're going to undo FOIL. So we want to end up with a binomial. So hopefully you all remember the idea of the product and the sum. So we want to have a sum of 2, and we want to have a product of negative 24. Okay, so what are our factors of negative 24 that will multiply to give us negative 24, and they will add together to give us 2? Well, we can start with, we got 1 and 24, we've got 2 and 12, we've got 3 and 8, and we've got 4 and 6. Well, 4 and 6 are going to be the two that I can add together to give us a sum of 2, because 6 minus 4 gives me 2. So, all I'm going to do is I'm going to use these two factors. I'm going to break them into my 4 and I've got x plus 6. And that is a successful factor. Now, the way we can check to see if this is correct is we just multiply it out. We do x squared minus 4x plus x minus 24, and then 6 minus 4 gives positive 2x minus 24. So, hey, look, this is exactly what we started with, so we didn't change anything, and that's going to be our final answer. I'm just multiplying it out to test and see if it was correct. For the next method, we're going to combine the factoring by undoing FOIL as well as the factoring by grouping. So what we're going to do is we're going to do product and sum again, but since we have this first term here, it's a little bit trickier. So we could figure out a product and sum using trial and error, but there's a technique that we use, it's a magic trick. So we're going to multiply 2 times negative 18. We're going to find a product of that. So we have 2 times negative 18, and that will give us negative 36. So we're going to find our product of negative 36, and we want our sum to be negative 9. Okay, and remember this is the magic trick. Alright, so factors of 36. We've got 1 and 36. We've got 2 and 18. We've got 3 and 9. Or not 9, 3 and 12. 3 and 12, and we want them to add to 9. So, looking here, I got 12. Well, 12 minus 3 gives us 9, so this is going to be the factors that I'm going to use. Okay. So, here's the whole trick. We're going to split this 9 into two different numbers. We're going to split them into 12 and 3. So, we're going to say 2y squared 12y. That 12 from right here plus 3y. And I got that 3 from right there. 18. Now I have 4 terms and I can factor that. So the whole thing that I did here is I just did negative 9y, which is the same thing as negative 12y plus 3. If I add these together, guess what? I get 9. Same exact thing. Now by grouping. So I can factor out a 2 from these. Factor when I factor out the 2y, I'm going to look at the right side of the equation. I can factor out a 3 from each of these, a positive, and I'm left with y minus 6. So hey, look at that. I have the same terms here, which is the goal of factoring by grouping. I forgot to get my y right here. So now I can put these together. I can give them 2y plus 3 and y minus 6. and I've arrived at my final answer. Now, the way we can check if it's correct, we just FOIL this out and see if we get the same thing that we started with. Alright, the last two examples we got here is working with perfect squares. So remember, from the first page, we had the difference in perfect squares, and we had perfect square trinomials. Term square. We can use our method from the first page. If we flip up, well, I don't have time to flip up, but what we're going to do is the square root of this first term is x, and the square root of this last term is 5. And then all we have to do is add a plus in between because of the 5 here. And looking at the first rule, all we have to do is write that twice. Let me scroll up and show you. Right here, we have the perfect square trinomial, so this was our first and our last term. We just have a plus b squared. So we have, from our example, x plus 5 squared. So we can write it x plus 5x. If you want to think about it, we can do the same thing. We can do the product and we can do the sum again. And this time our product is going to be 25. And the factors of 25 are going to be, well, we know we're going to use 5 times 5 because those add to give us our sum, which is 10. So it's positive 5 plus positive 5. That'll give us the difference in square, or the square trinomial is just a shortcut that we can use, as well as the difference in squares. So let's scroll up and take a look at our difference in squares. We have the first term minus the second term, then we have the first term plus the second term, or the square root of the first term plus the second term, and the square root of the first term minus the second term. So that's the same technique. We're going to say, is there a perfect square? Well, 12b squared is 27 squared. And now what I have is square root b. I'm going to be okay, and if I say the square root of 9c squared, or the square root of 9 is 3, and the square root of c squared is c. So now all I have to do is 3. I'm going to do the square root of the first term, which is 2 the fourth, plus the square root of the second term, which is 3c, times the square root of the first term, which is 2b to the fourth, minus the square root of the second term, which is 3c. And so that will be our final answer for using the difference in squares. I just took the square root of the first term and the second term, and then added them together, and then subtracted them together. So, a couple of notes. First thing we want to do is we're going to look and see if there is a greatest common factor. Always going to be the easiest way to solve this. We also want to ask ourselves, how many terms are there? If there's 2 terms, can we use the difference in squares? If there's 3 terms, then we can use our product and sum technique. If there's 4 more terms, then we're going to look and see if we can do. Alright, so